Okay, back to 9.3. Likewise, given that u and v are continuous on a closed interval ab, then the following rules can be applied. The indefinite integral of the vector valued function r of t dt is equivalent to the integral of the u of t dt times I plus the integral of v of t dt times j. And the definite integral from a to b of the vector valued function r of t dt is equivalent to the integral from a to b of u of t dt times I plus the integral from a to b of v of t dt times j. So now we've got a couple of examples here. Given the functions r of t equals t squared I plus j, u of t equals ln ti minus tj, and w of t equals e to the 2t, find each of the following. Notice that the ones that are bolded are vector valued functions. The one that is not bolded is just a regular function, okay? And so for part A, d dt of the vector valued function r of t dot u of t, and we remember that this is going to be r times u prime plus u times r prime. And then just to the side, the r prime of t will be the vector 2t comma 0, because that would be the derivative of t squared is 2t, the derivative of 1 is 0. And then your u prime of t would be 1 over t comma negative 1. So those are your two derivatives, and now we can, now we can apply this formula, okay? So we've got our r, which is our t squared I plus j, times our u prime, which is going to be 1 over t I minus j, and then plus, we've got our ln t times I minus our t times j times our r prime, which is just going to be 2t times I. You could say plus 0j if you wanted to, or you can just leave it 2ti. So now, what we have is we have our t squared times 1 over t, because the dot product of I times I is 1. And then we've got our plus 1 times negative 1. And because our dot product of j times j, or j dot j, is 1. And then plus, we've got our ln t times 2t plus our negative t times 0. And then simplifying that gives us t minus 1 plus 2t ln t. So that would be the answer to our derivative of our dot product. And then part B, this is just a function being multiplied by a vector valued function. So we will be using our w times u prime plus u times w prime with our w prime of t equaling 2e to the 2t, and our u prime of t, I'm just going to write it in vector form of 1 over t comma negative 1 like we did on the first example. And so now putting these two things into our formula here, we have our e to the 2t times our 1 over t comma negative 1 plus, and then we've got our w prime, I'm going to put first 2e to the 2t times our ln t comma negative t for our u. And so from there, you can see that if you wanted to leave it in that vector form, that these are both being multiplied by e to the 2t. And so you could keep that on the outside if you wanted to, and distribute the 2 on the inside of the second term, and add those together. Add the first ones together because they are being multiplied by the I. So if I distribute the 2, this would be plus 2 ln t, comma, and then this would be negative 1 minus t. Or I'm sorry, minus 2t, excuse me. Got to distribute the 2 to that one also. So you could write your answer like that. I'm just going to leave it like that just as another way to write it. Okay, part C. Derivative of a vector valued function times a regular function. So we've got our r times w prime plus our w times r prime. So our r in vector form, t squared comma 1 times our w prime, which is our times 2e to the 2t, plus our e to the 2t times our r prime, 2t comma 0. And again, you can see that e to the 2t is on the outside. And if you added those and distributed your 2, you would end up with 2t squared plus 2t for your I value. And distribute the 2 plus 0 would just give you 2 for your j value. Or since you saw that 2 was in both of them, you could also write it as bringing that 2 out front. This would be t squared plus t, comma 1. Both of these would work. And then for part D, this is a chain rule function. So if we could look at this a couple of different ways, but if we look at this as d dt of, and putting our e to the 2t in for t, because that one was, r was t squared times I plus j. And then if you go ahead and think of this as e to the 4t I plus j, then you could say that this derivative is 4e to the 4t comma 0. And that's probably the way, that's the easiest way to do it. Example number 9. Find the indefinite integral. So I probably would write this as 2 times the integral of t minus 1 to the 1/2 dt times I plus the integral of sine t dt times j. And so this is going to be 2 times t minus 1 to the 3/2, and then division by 3/2 is multiplication by 2/3 I plus, what can I take the derivative of that will give me sine? That would be negative cosine t times j, and then plus c. So this would be 4/3 times t minus 1 to the 3/2 times I minus cosine t times j plus c. And then part B, integral e to the 2t dt times I plus integral 1 over t minus 1 dt times j. This is going to be e to the negative 2t and then divided by negative 2 times I plus ln absolute value of t minus 1 and then plus, or times j, and then plus c. So negative 1/2 e to the negative 2t I plus ln absolute value of t minus 1 times j plus c. And then example number 10, these are definite integrals. So integral from 0 to 3, 3t squared minus t dt times I plus integral from 0 to 3, 4t cubed plus t dt times j. So this gives us t cubed minus 1/2 t squared from 0 to 3 I plus t to the 4th plus 1/2 t squared from 0 to 3 times j, which is 3 to the 3rd minus 3 squared over 2, and then minus 0 would just give you 0. I plus, and this would be 3 to the 4th plus 3 squared over 2 minus 0 would just give you 0. So don't worry about that, times j. So this is 27 minus 9/2 I plus 81 plus 9/2 j. And if I change these all to halves, this would be 54 halves minus 9/2. Which would be 45 halves I. So I'm just going to put that over here. 45 halves I. And then plus, this one would be 162 over 2 plus 9/2 times j, which would give you 171/2 j. Okay, so that's the answer to A. And now B, I'm going to do it in a different color. This one, integral from 0 to pi over 2 e to the t dt times I plus integral from 0 to pi over 2 sine of 2t dt times j. And this would be e to the t from 0 to pi over 2 I plus this one is going to be negative 1/2 cosine 2t from 0 to pi over 2 times j. So e to the pi over 2 minus e to the 0 times I plus negative cosine of pi, because the 2's would cancel, divided by 2, minus a negative, which would be plus cosine of 0 over 2 times j. And I'm just going to write it down here. E to the pi over 2 minus 1 times I plus, and then this would be minus a minus 1 over 2, so plus 1/2 plus 1/2 j gives me e to the pi over 2 minus 1 times I plus 1 j as your final answer. And then just a couple more examples here. Example number 11. Find r of t equals the integral of cosine ti plus sine tj dt, given that r of 0 is I minus j. Okay. So we've got r of t is equal to, now if I integrated cosine, I would get sine t plus c. And that would be times I. And if I integrated sine, I would get negative cosine, so plus negative cosine t plus c. And by the way, this would be, I mean, it might be the same, but you're going to have to make these different c's times j, because they're different situations. So now if we let t equals 0 and r of 0 equal I minus j, then our r of 0 equals sine of 0, which is 0, plus c1 times I, plus, and then this would be negative 1 plus c2, because if I put negative cosine of 0, that would be negative 1. So negative 1 plus c2 times j, that would be our r of 0. And that would, as we said, have to equal I minus j. So therefore, our c1 must be 1 for that to be true, and our c2 must be 0 for that to be true. So therefore, r of t is equal to, and now we put our c1 and c2 back in, so it's sine t plus 1 I, and then we could say minus cosine t j. Okay. And then our last example, number 12, if the path of a particle r prime of t equals 3t squared I plus 6 times the square root of tj, and r of 0 equals I plus 4j, what is the particle's position at t equals 4? There's two ways to solve this problem. One of them, to find your r of t, you could integrate your 3t squared I plus 6 square root of tj dt. And when you did that, you get t cubed plus c1 times I plus, and the integration here would be 1/2 plus 2/2, so it'd be 3/2, but your 6 would get multiplied by 2/3 plus c2 times j. Let's say divide by 3, I get 1, divide by 3, I get 2. And then at the very end, you would have your plus c3 because you're integrating the whole thing. So there's that constant at the end that could have been there. So if we say let t equal 0 and r of 0 equal I plus 4j, r of 0, because this was our r of t, right? I didn't write it, but I should have. So this is our r of t. So our r of 0 would be 0 plus c1, because 0 to the third power is 0, times I, plus, and this is 4 times 0 to the 3/2, which is going to give you 0, plus c2 times j, and then plus our c3. But we know this has to equal I plus 4j. So that means C1 has to be 1, and our C2, because this whole thing went to 0, has to be 4, and our C3 had to be 0. So therefore, our r of t equals, put the 1 in for the c1, so that's t cubed plus 1 times I. Put the 4 in for our c2, so plus 4t to the 3/2 plus 4j. And then we would look for our r of 4, because that's what they're asking, the particle's position. This is a position function, so its position at 4 is going to be 4 to the third plus 1, I, plus 4, and then I'm going to look at this as square root of 4 to the third power plus 4 times j. So 65I plus, this would be 8 times 4 is 32 plus 4 is 36j. So this is its position 4 at t equals 4. An alternate, which I'll put in a different color, you could have said that the x at 4 is going to be equivalent to this 1, that its position is at 0, plus the integral from 0 to 4 of the 3t squared dt, and your y is going to be this 4, so 4 plus the integral from 0 to 4 of your 6 square root of t dt. And so if you solved, I'm going to go ahead and put a line here, and I'm going to solve for my x. 1 plus, this would be t cubed from 0 to 4. So 1 plus 4 cubed minus 0 cubed. So that's going to be 65 for your x value. Your y value, 4 plus, this would be t to the 3 halves. And then 6 times 2/3 we said was 4. That from 0 to 4. So 4 plus, and square root of 4 is 2 to the 3rd power is 8 times 4 is 32. So that would be 36. Giving you your R of 4 equals 65I plus 36J.